have visitors. Welcome to the International Space Station in the year 2057. I'm Matt Sabernack, and I'm talking to you from the not-too-distant future to give you a better insight into the workings of our solar system. As you probably know, even in your time, mankind has undertaken numerous unmanned missions to our neighboring planets. We've even succeeded in landing a remote-controlled vehicle on Mars. And these took photos of their surroundings, photos just like the ones you would take outside your front door. Looking at real snapshots from faraway worlds is pretty exciting. And I have good news for you. In my time, our advanced NOMAD rovers are out there everywhere, stationed throughout our solar system and beyond. So let me take you on a little tour to have a closer look at the 8 major planets of our solar system, their biggest moons, and of course some of the most breathtaking views our galaxy has to offer. And while we're at it, we'll look for extraterrestrial life, of course, a possibility which has fueled mankind's imagination for centuries. The question of how our Earth and even our Sun were created originally and developed into their current forms will also be answered along the ride. The main focus of our mission is the planets of our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. First of all, you may wonder where these planets have come from originally. They haven't been there forever. They emerged billions of years ago. We cannot look into this distant past, but in the almost infinite depths of space that surround us, new suns and planets are born virtually all the time. Nebulae like this one are interstellar clouds of dust and gas. The area we're looking at is spread over 200 light years. That means if we could travel at the speed of light, it would take us 200 years to travel from the left border of the screen to the right. The stardust consists of crystals, amorphous substances, and molecular chains. When this diverse matter is exposed to massive pressure, a chain reaction is set into motion that leads to the creation of new suns and planets. In this case here, the gigantic star Eta Carinae is the father of numerous baby stars, in a manner of speaking. Eta Carinae has a mass 100 times greater than our Sun. It's so big it can hardly keep itself together. Some experts believe that Eta Carinae could even explode within 100 years. Hardly a bat of an eye when thinking in cosmic timelines. Here we have the southern pillars of the Carina Nebula. The dust clouds here are so dense that no light can pass through, but with our infrared cameras depicting heat sources, we can lift that veil and have a look inside. Now, the future baby stars are visible as yellow or white dots. They are cocooned in finger-like tubes, shown in pink. The star Eta Carinae is just outside the top of the frame. Like all suns, it doesn't only emit light, but also strong radiation and energy-charged particles. These stellar winds have blown the stardust in front of them, and chaotic shapes of veins and pillars have formed. Over a time period of millions of years, new solar systems will develop here. Just like our own Sun, most of these small, bright dots will have their own planets that circle around them. But as long as mankind hasn't developed any hyper-light-speed drives, we better have a closer look at our neighboring planets instead. Let's start with Mars. As you probably know, the red planet has been the destination of a handful of artificial visitors, probes, landers, and rovers. Even the early models were equipped with digital cameras, some even capable of creating three-dimensional images. That way, mankind became witness to the wide plains and rugged chasms of Mars. With the current technology, this whole experience gets even more impressive. Mars is a rocky body just like Earth. But it's only half the diameter of our home planet, which makes it the second smallest planet of our solar system. Its red color comes from vast amounts of iron oxide, also known as rust, that is spread throughout the planet and the atmosphere. Speaking of which, the atmosphere is rather thin as opposed to Earth. This results in Mars not being able to store much of the sun's warmth. Near the equator, temperatures are around 32 degrees Fahrenheit during daytime. At night, it plummets to as cold as minus 121. If you're looking to camp here, you should definitely pack warm clothes. The air on Mars is very dusty and is mainly made of carbon dioxide. So humans cannot breathe here. Also, the high pressure would make your skin boil, so better bring a spacesuit. Aside from these facts, Mars would surely be an interesting holiday destination. After all, it's got varying weather conditions and seasons just like back on Earth. The southern hemisphere of Mars is generally warmer than the northern counterpart. Between them, temperatures can vary as much as 80 degrees. In summer, the pole caps made of ice melt down, which allows for distinctive cirrus clouds to form. We can actually see these in the sky here. In spring, storms are common which whip up vast quantities of Martian dust. With wind speeds of up to 400 miles an hour, a lot of the surface is cast under a dusty veil. Sometimes, even small cyclones called dust devils come up. The extensive landscapes on Mars have quite a bit to offer. Again, here are major differences between the northern and southern regions. In the cooler north, we find the low plains, which are broad, dust-covered flatlands with names like Utopia planitia or Amazonas planitia. Dark areas have been visible on the surface of Mars since early telescopes were invented. These were thought to be oceans. However, the truth is that Mars is somewhat dry, with only tiny amounts of water. The southern hemisphere has geologically older formations and more craters. For example, the highland region of Arabia Terra is densely cratered. Among the numerous impact craters in the southern region is the biggest Mars crater, called Hellas Planitia. The basin has a diameter of 1,300 miles with a low point of 5 miles below the ground level of Mars, making it the lowest point on the entire planet. Running parallel to the equator is the Valles Marineris. These Mariner Valleys are the largest known rift system of our solar system. It stretches out for over 2,500 miles and is up to 440 miles wide and runs up to 5 miles deep. It is a giant tectonic crack of unknown origin. In the western part, called Noctis Labyrinthus, it develops into a chaotic entanglement of rifts and valleys which are up to 12 miles wide and up to 3 miles deep. While on the topic of proportions, Mars holds at least 2 records, one being the giant volcano Alba Patera, which covers the widest area of all volcanoes with a diameter of 1,000 miles. With a height of around 4 miles, it's not as tall as Mount Everest. However, Mars also has the Olympus Mons. Measuring an impressive height of 16 miles, it dominates the surrounding plains and makes it the highest elevation in our whole solar system. Apart from Earth, Mars is by far the planet most thoroughly explored and researched by mankind. We know that Mars must have had a much denser atmosphere millions of years ago and is likely to have had lots of liquid water on its surface. Back then, it offered much better conditions for the creation of life. That changed when its atmosphere was thinned out by solar winds. Still, in the ice of its polar caps, there could be primitive life in the form of bacteria or microbes. After all, such life has been found in the perpetual ice of our own poles.
Well, as you can see, there's a lot going on out there in space, even if we haven't encountered any aliens yet. But let's start at the beginning.
7,000 light-years away in the star constellation of the Serpent lies the Eagle Nebula. It's 95 light-years high, which equals about 55 trillion miles. As a comparison,
our solar system is a mere 10 billion miles long, or in short, the Eagle Nebula is kind of large. In the Eagle Nebula, stars are born from clouds of cold hydrogen. These clouds are blown apart by the emissions from the already active suns, creating chaotic shapes of incredible beauty. Sitting above the top of this structure are gigantic hot suns that illuminate these shapes, and thereby render their three-dimensional shape visible. At the same time, their solar winds are thinning out this gigantic object. This star factory must have been formed in a particularly dense hydrogen nebula that eventually collapsed. It became denser and denser until the high pressure triggered an explosion, like in an atomic bomb. It heated up other cold dust clouds, eventually driving them to an ignition. This caused shock waves that swept through the formation. The edge of one such shock wave is visible in the brighter contour that defines the upper left corner of the nebula. The heated gas has the effect of a battering ram on denser clouds of cold gas. It compresses and eventually ignites them, and the cycle continues. You may be asking how this cosmic chain reaction begun in the first place. The infrared spectrum of the nebula provides the answer. Here we see the cold accumulations of hydrogen in a greenish tone. The red hues show the hot dust, and its concentric distribution provides an explanation to its inception. About 8,000 years ago, a gigantic star exploded right in that center, and the energy from this explosion triggered the chain reaction. At the same time, the shock wave generated by the explosion also drove the cloud apart, which in effect caused the most dense region to move slowest. The dense gas clouds have become the birth grounds of new stars. Among them are the famous pillars of creation. This sensational photograph was taken by the Hubble Space Telescope in the year 1995.
Now, this is a relatively recent picture by human standards. These pillars crumbled thousands of years ago, driven apart by the cosmic radiation of the suns. How is this possible? Well, it takes light 7,000 years to travel from there to here. That means when these light rays finally arrive at the sensors of our cameras, they show a very distant past. Now, to get a better feeling for dimensions as incredibly vast as these, let's consider the composition of our own solar system.
As we can see here, Mercury, Venus, Earth, and Mars are, relatively speaking, close to one another. If you look at the entire composition, you could almost say they're cuddling. Mars is followed by an asteroid belt, after which the distances between the planets grow larger and larger. Last in line is Neptune. Neptune is 2.7 billion miles away from the Earth, which doesn't even amount to a light year in distance. In fact, this distance is equivalent to a mere 4 light hours. To put that into context, if someone flashed a gigantic light on Neptune, we would be able to see it on Earth 4 hours later. From a distance, Neptune appears to be a blue sphere, a color which is reminiscent of planet Earth's oceans. This is why Neptune was named after the Roman god of the seas. Actually, the color is due to the fact that Neptune's atmosphere is made up mostly of methane. Because of its properties, methane absorbs red light. In the upper layers of the atmosphere, we see gigantic clouds several thousand miles long. They form in stripes because of the high rotation speed of the planet. At the poles, we have auroras, northern lights that look much more complex than those we have on Earth. This phenomenon occurs when charged particles of the solar winds enter the atmosphere. Besides its 17 moons, Neptune is also accompanied by its rings. These rings are changeable in size and shape. The biggest one of them, called the Adam's ring, has a slightly red hue. The majority of the rings appear rather dark though, rendering them difficult to see. They're mostly made up of dust and small particles the size of grains of sand. Neptune is a so-called gas giant, meaning that the planet is almost exclusively made up by its atmosphere. In this thick soup, we have wind speeds of up to 1,200 miles per hour. On the way to the stony core, which is almost as large as the entire planet Earth, the pressure grows massively. Our NOMAD would be squashed in a matter of seconds if it went any lower. In fact, there isn't even a defined surface due to the pressure. The atmosphere gets liquefied without transition, which results in there not being much to see on the way down, just a wild spray of methane, ammonia, and water. I guess it's safe to say Neptune is not the nicest place to visit. Its biggest moon, Triton, is definitely more welcoming. This son of Poseidon is a bit smaller than our Earth moon. Despite its small mass, it has an atmosphere which is less than 1% as dense as ours. Triton's surface is covered by a thick crust of ice. Cracks and deformations on the surface make up a network of disturbances, which is a sign of geological activity. And really, there are geysers on Triton. They shoot up through the surface ice, forming fountains into the atmosphere, some as high as 5 miles. Atmospheric winds spread the icy dust over great distances until it settles back down on the side facing away from the sun. The half of Triton that is in the shade has temperatures down to minus 394 degrees. This is the lowest temperature ever measured in our solar system. Such a winter lasts for 40 years on Triton. Another fascinating peculiarity is that it moves in the opposite direction to Neptune's rotation. At the same time, it's fairly close to Neptune, so incredible tidal forces are created due to gravitation. These forces are believed to be responsible for the cold volcanism of the geysers. In the long run, Triton isn't going to remain in this position. It is forced closer and closer to Neptune. In a few 100 million years, it will collide with Neptune, which will cause it to be ripped apart. The debris will form a much denser ring system around Neptune, resulting in a look similar to Saturn. Until then, there's plenty of time to take in the breathtaking view of Neptune. From here, we can also see its second biggest moon, Proteus.
Well, again, we haven't had much success with our search for alien life out there. This begs the question of why so many people believe in extraterrestrial beings. A statistical explanation might be given by the laws of probability. Out there in space, there are more stars than grains of sand on the entire planet Earth. Now, with that in mind, how could we be the only star system with intelligent life? The probability of there not being life anywhere else in the universe seems about as likely as a single person winning a lottery jackpot 100 times in a row. Now, humans tend to see familiar shapes in astral objects, like the face of the moon or the shapes of the constellations.
Even experts in astronomy typically name their findings on that basis. That's why, for example, the Omega Nebula in the sign of Sagittarius hasn't solely been ascribed a scientific name such as M17 or NGC 6618. This phenomena has also been given more poetic names like Horseshoe Nebula or Swan Nebula, and we will now embark on a little excursion to find the hidden dragon there. The Omega Nebula is so bright that it is visible to the naked eye from Earth. You can only see it as a gray lump, though. You'd have to use the right equipment in order to reveal its true beauty. With images taken using visible light, the first thing you notice is the very bright region at the bottom left. This is lit by O stars. Stars are categorized into different classes, with O stars being the heaviest and hottest. They emit blue light. When we switch over to the infrared camera, we reveal the shape of a fantastic fire drake spreading its wings to take flight, which was previously hidden. This is a cloud of matter so dense it cannot even be penetrated by infrared light, which reveals this formation. The scientific name for this cloud is M17 Swex, and inside, baby stars are hatching at an amazing rate. So far, no O-stars have formed there, but one day they will light up the whole area that now lies in darkness. It will bathe in their bright light, just like Omega itself.
You see, in addition to the gazillions of possible habitats for alien life forms, many more are being created as we speak. And it's still questionable if mankind will ever be able to reach them, given the fact that even the light of these suns takes thousands of years to reach us. Since the beginnings of human space travel, my fellow astronauts have said that seeing the Earth from up here is one of the most astonishing things you can experience with your own eyes. So hold on to your seats. But before we travel out there, let's briefly take a look at how Earth came to be in the first place.
We're taking a little detour to the Orion Nebula. Here lies a star-forming area which is 1,500 light-years away. It appears as the bright region in the Sword of Orion, located in the sign of the Hunter. In this incredible cosmic configuration, somewhere between 1,000 and 2,000 young stars are in the making. These are made by 4 of the largest stars in the galaxy, called the trapezium. Many of these stars will later be surrounded by planets formed in the process. Around this trapezoid, we find newborn suns that are surrounded by so-called protoplanetary disks. These protoplanetary disks are vast accumulations of material, perpetually drawn to the center of gravity. In that center, a new star is forming. After the ignition of the star, leftover material continues to circle around it. Through the process of accretion, the concentration of these cosmic particles, bigger masses of material start to form. As these grow larger, they grow into what we call asteroids. Directed by the sun's gravitational attraction, the asteroids move around at high pace. They crash into each other repeatedly, resulting in the forming of bigger masses of rock. Eventually, some of these asteroids grow large enough to have a significant gravitational pull, and therefore pick up more and more material. Over time, this process leads them to become planets. Some of these planets even develop an atmosphere by collecting particles of gas floating through the surrounding space. For example, in this image, hydrogen and sulfur are visible in a greenish tone, and carbon-rich molecules have an orange-red hue. The yellow specks of light are the young stars that are deeply encased in cocoons of dust and gas. The Orion Nebula is also home to some brown dwarfs. That's what we call failed stars, meaning that they weren't able to collect enough mass to keep a constant nuclear reaction running. In essence, a sun is a gigantic fusion reactor. Fortunately enough, the Earth's sun has been running steadily for approximately 5 billion years now. So let's have a look at this hot center of our solar system. The 8 planets of our solar system are circling around the star in their center on elliptical orbits with differing trajectories. Earth has a mean distance of around 100 million miles from the Sun. In order to be able to look at the Sun with our human eyes, we need to decrease its luminosity by 98%. We're now looking at the pulsating surface, where temperatures soar up to 3.5 million degrees Fahrenheit. In the very core of the Sun, it reaches 27 million degrees because hydrogen is constantly fused into helium. The fusion reaction causes the release of energy in the form of photon rays. These photons dart around at light speed. But as they collide with matter frequently, it takes 1,000 years on average for them to finally leave the Sun's center because it's so dense. Compare that to the mere 8 minutes it takes for the photons to reach Earth once they've escaped the sun's center. In this light from the sun, Earth predominantly glows in the luscious blue of its oceans. The continents appear mostly brownish and dark, while the second most dominating color is white, due to the white clouds in our atmosphere combined with the vast ice crusts at the poles. Seen from space, everything looks smooth and quiet. This is a stark contrast to the violent affair characterizing its creation. After a core had formed from materials of the sun's protoplanetary disk, the young Earth was subject to a constant bombardment of asteroids and other celestial bodies. One particularly heavy asteroid ripped off a part of the Earth's mantle. This rubble remained in orbit and supposedly formed the moon over the course of the millennia. As the rate of the bombardment finally decreased, Earth slowly cooled off, resulting in the forming of a solid crust of stone on the surface. Still, there were frequent volcanic eruptions as well as gases, which eventually formed an atmosphere. Vaporized water condensed and returned to the surface in the form of rain, while meteors of ice filled up the first oceans. A hydrological cycle was set into motion, and over the subsequent millions of years, evaporation and rainfall eroded the rocky surface of Earth. The first supercontinent broke apart several times over, and in time, land masses took the shapes of the continents we know today.
Eventually, life appeared on Earth. It probably began with amoeba in the water, continuing to fishes and on to land life, reptiles, birds, and mammals, and eventually man. Scientists are still exploring the wonder of life's creation and its prerequisites. The most common assumption is that water, oxygen, and sunlight were the needed ingredients to get things started here on Earth. But all of these wouldn't have done much without another all-important factor: Earth's magnetic field.
This huge force field shields us from deadly radiation from the sun. The magnetism is created by complex geodynamical activity. It diverts solar winds around our planet, preventing them from diminishing our atmosphere and oceans. So without the crucial magnetic field, Earth would probably have become as barren and bleak as our silent companion, the Moon. Being the closest astral body to Earth, the Moon has fueled the imagination of mankind for millennia. The idea of extraterrestrial life on the Moon has been communicated through paintings, songs, and literature. Even some of the first silent movies depicted life on the Moon. But by the time man first set foot on the Moon in 1969, it was rightly anticipated that the astronauts would not encounter any moonsfolk. Regardless of the absence of extraterrestrial life forms, the Moon remains truly fascinating. With a diameter of 2,000 miles, Earth's companion is the fifth largest moon in our solar system. The Moon needs 4 weeks to orbit once around the Earth, a fact that is mirrored in our everyday language. The word month is a derivative of moon. Through its gravitational pull, the Moon bears significant effects on Earth. The most visible effect is our tidal system. The Moon also plays a role in maintaining the crucial magnetic field. The Moon even bears an effect on Earth's biosphere. Some species, including birds and insects, make use of the Moon for navigational purposes. As far as looks are concerned, the Moon remains a bit dull because of it being completely covered in gray dust. The dust layer is produced by meteor strikes. Because of the lack of atmosphere, meteors crash onto the surface of the Moon without any damping and are pulverized in the process. The moon dust produced this way actually resembles sand, or scientifically speaking, regolith. So far, water has only been traced in microscopic quantities. Nevertheless, we still group the Moon's surface into areas of lands and seas. We talk about lands and seas on the Moon today because of earlier times' scientific beliefs that the dark areas on the Moon contained water. We now know that those seas are in fact basins of solidified lava. Most likely they were created by heavy asteroid hits during the Moon's early days. At that time, the Moon's crust was still molten underneath, and therefore the craters created by the asteroid's impact became filled with lava. Interestingly enough, the Moon is still geologically active today. To be more precise, the activity is so fierce that moonquakes occur up to 10 times a day. Most of these are moderate, but some reach up to level 5 on the Richter scale. On Earth, this would be enough to seriously damage unprotected buildings. Well, fortunately, there are no buildings here, and the craters don't seem to mind a little moonquake from time to time. Even if the Moon's landscape is lacking in variation, you still have a great view from here. Our blue mother planet rises majestically, and you also get a perfect view of the stars, without an atmosphere or light pollution hindering the outlook like it does from Earth. Let's head out for another visit up there. About 6,500 light-years away, in the star sign Cassiopeia, there are two neighboring nebulas, the Heart and the Soul Nebula. Here we find several generations of stars in a distinct configuration. These images provide the most convincing evidence for the most widely acknowledged theory explaining how stars are created. In each of the centers of two large cavities, we find a very old star, both close to 10 times bigger than our own Sun. Over the course of millions of years, the radiation from these two large stars has swept away the surrounding stardust. In that process, a mixture of matter and gas is compressed, ultimately triggering the ignition of new stars. Accordingly, the outer areas of these two cavities are lined with young stars. We see them here as pink dots at the pointy ends of the tubular pillars. If we go a bit closer, we'll discover a formation that scientists have called the Mountains of Creation. This is a reference to the Pillars of Creation in the Orion Nebula that we saw earlier. The Pillars of Creation are only tiny fingers when compared to the Mountains of Creation. Here you see the two side by side with a matching in scale. This section alone of the Mountains of Creation is 50 light-years wide, which is equal to 295 trillion miles. In the central formation, hundreds of emerging stars are visible. They appear in a yellow-white tone. The matter visible in red consists of aromatic hydrocarbonates. It's heated by the light of the young stars and thus becomes visible to our thermal cameras. If we were to wait a couple of million years, new planets would emerge here as well. But I think I don't have the patience for that. So let's return to our own stellar neighborhood and inspect some existing planets.
Now, landing a man on the Moon denoted a great triumph for mankind and for science in general. Other manned missions into space have been in planning since then. The target has always been Mars. When you consider the fact that Venus is actually our nearest neighbor, this seems a little strange. Unfortunately, we have a NOMAD unit right down there on Venus at this moment. Let's switch over to the live-action camera to see for ourselves why the conditions are not too welcoming.
Venus is the second brightest object on our earthly sky. Due to its low orbit, Venus is hardly visible during nighttime and is therefore known as the evening star. Sometimes it's bright enough to be visible to the human eye during daytime. The reason we're able to see Venus this clearly is due to its dense and light-reflecting atmosphere, combined with its close proximity to Earth. In fact, Venus is not only positioned close to Earth, it also bears similarities with a number of key physical properties, to the degree to which the two planets are often referred to as sister planets. Venus has approximately the same size, density, and mass as Earth. Likewise, the gravitational force is close to 90%. In spite of these resemblances, there are major differences. The atmosphere is so dense that it completely shields the surface from our visual field. Good thing we can always rely on radar and infrared cameras. So let's take a closer look at Venus's surface. The average surface temperature on Venus is 867 degrees Fahrenheit, which makes Venus the hottest Earth-like planet in our solar system. The first Russian probes to arrive here in the second half of the 20th century were literally crushed by atmospheric pressure. Venus has a surface air pressure equaling the pressures found at 4,000 feet below sea level in Earth's oceans. Luckily, our nomads are much more durable. Looking around down here, it seems perfectly fair to agree with claims that downtown Venus resembles popular depictions of hell. Sulfuric clouds, acid rain, and active volcanoes are all on the list of local attractions, alongside dimly red glowing surfaces littered with craters. And with the aid of radar image systems, we were able to investigate the local topography. Logically enough, there's no water on the surface because of the high temperatures. That doesn't prevent us from geologically distinguishing between high and lowlands. The two highest plains could be described as the continents of Venus. The one we see here carries the name Ishtar Terra and is placed in the northern parts of Venus. The area is about the size of Australia and is home to the Maxwell Mountains, among others. Its peaks reach over 6 miles, similar to the Himalaya Mountains back on Earth. The other continental formation is named Aphrodite Terra and covers an area the size of South America. It runs across the equator, shaped in a formation that looks like the outline of a scorpion. This land of Aphrodite consists of 3 bulged formations called Ovda, Thetis, and Atla Regio. The Atla Regio is divided by gigantic trenches. These steep-walled valleys, or chasmas, look similar to the canyons of North America. Atla Regio is adorned with huge volcanoes. Among them is Mat Mons, a giant of 5 miles towering over the other Venusian volcanoes. In total, there are over 50,000 of them. It's not surprising that the whole surface area of Venus is composed of shapes made of solidified lava. Among them are some rather strange-looking specimens, like these circular pressure domes, suitably called pancakes. Other distinctive features of Venus are lava channels of incredible length. They have an average width and depth of 1 mile and run for thousands and thousands of miles. The longest one, called Hilder Fossa, is some 4,200 miles long, outcompeting the reach of the Nile, Earth's longest river. Another feature of Venus, or more accurately, lack of feature, is the absence of a moon. Standing on Venus's surface, you wouldn't have been able to see a moon anyway, because of the thick atmosphere. These thick layers of clouds not only obscure our visual field, but may well hide Venus's biggest secret. Some scientists claim that it's plausible that microorganisms inhabit these clouds.
Well, to be honest, using NOMAD's advanced sensors, I could easily reveal the truth about whether or not microorganisms live here. But I don't want to spoil all the fun. But you know, since life could somehow emerge in the primordial ooze of our Earth millions of years ago, why shouldn't it have happened elsewhere too? Or maybe it's happening right now as we speak. And why not in our nearest vicinity? Venus, after all, is located only marginally outside the calculated habitable zone of our solar system.
Mankind can only find answers to that big question through research. Satellites and probes will have to be sent up there. They will have to scan, sample, and analyze large amounts of data. Although we live in a highly progressive and technologically advanced time, large portions of our own solar system still remain in the dark. As we have seen, there is a ring of asteroids separating the orbits of Mars and Saturn. Neptune is the outermost one of our major planets, but our solar system stretches much farther. Behind Neptune, we find a huge asteroid field called the Kuiper Belt. It's 20 times wider than the central asteroid ring and is home to over 70,000 objects of more than 60 miles in size. These objects are leftovers from the creation of our solar system, material that wasn't included in the formation of our planets. Some of these objects came very close to transforming into planets. Best known among them is Pluto. From 1930 until 2006, it was officially defined as the 9th planet of our solar system. When the trans-Neptunian object Eris was discovered in 2005, the media quickly announced it to be our 10th planet. The scientific community decided differently and came up with a new category to accommodate these types of objects: dwarf planets. In the process, the similar-sized Pluto lost its status as a regular planet. As scientists look closer into the Kuiper Belt, more and more dwarf planets are discovered. All trans-Neptunian planets have been named after earthly deities, for example, Makemake, a Polynesian god. Then there is Sedna, the Inuit goddess of the sea, or the distinctively ellipsoid Haumea, named after the Hawaiian goddess of childbirth. While our scientists act as diligent midwives, finding and naming more and more of these little rascals, it's near impossible to acquire any meaningful data on these new arrivals while sitting here on Earth. Even the only dwarf planet of the inner solar system remains mostly unexplored. Ceres sits right between Mars and Jupiter and has a diameter of around 600 miles. It supposedly carries a significant amount of water ice, which has led to speculation that life may exist there.
That's why our engineers work around the clock to build more probes. Hopefully, we'll have more data on Ceres and the trans-Neptunian dwarf planets in a couple of years. Current spacecraft take about 9 years to reach Neptune, though, so this might take a while. The view of Earth from here is breathtaking, and as we've already discovered, outer space continues to hold a number of surprises in store for us. Today, you may be surprised by the appearance of some of the faraway planets we're about to visit. We have even deeper insights in store too. You may recall that we previously unraveled how planets and stars come into existence, but as the saying goes, what goes around comes around, and everything has an end. Even incredibly powerful objects like our sun. I'm going to show you what that looks like.
The sign of Taurus is home to one of the most interesting and most studied objects of visible space, the Crab Nebula. The torn and furrowed appearance of this stellar nebula gives a strong hint as to what has happened here. A star exploded. As we know, the Sun can be described as a gigantic fusion reactor. At any given time, helium and oxygen detonate inside of it. Under most circumstances, the detonation of helium and oxygen would result in a star blowing into pieces. But the Sun's incredible gravity prevents that from happening. Over the time of billions of years, this interaction depletes matter. In the case of the Crab Sun, gravity eventually lost the battle. The Crab Sun exploded around 1,000 years ago, in the year 1054 AD. The explosion was so bright that it could be seen during daytime, according to ancient Chinese astronomers. During the 1,000 years that have passed since, the remaining core of the Crab Sun has turned into an extremely dense neutron star. It continues to spawn a large number of high-energy particles, and therefore the Crab Nebula takes an ever-changing shape.
Well, in case you're wondering, yes, one day our sun will unfortunately share a similar fate. But don't worry, it should still be good for another couple of billion years. When that day comes, the sun's first victim will be its closest planet, Mercury. Now, in addition to the threat from the sun, Mercury is having a bit of a rough time in general. So let's not waste time talking. Let's have a closer look instead. After all, in a few billion years, it might be too late.
Mercury is the last Earth-like planet in our solar system. Actually, apart from having a rocky body like Earth, it has not many other earthly properties. Visually, this planet resembles the Moon. This corresponds well with Mercury being the smallest regular planet in our solar system. Mercury does not have an atmosphere, something which is evident from its crater-littered surface. There is nothing preventing meteorites from hitting Mercury at full speed. From up here, these craters may misguidingly look like innocent footprints in sand, but if we go up close, they reveal their true size. They are gigantic. The 10 largest craters have diameters ranging from 125 to 1,000 miles. The largest one is known as Caloris Basin. This huge dent can only have been created through the impact of an astral body at least 60 miles in width. As a result of this brutal impact, the crust of Mercury's surface was cracked, allowing for the basin to be flooded with lava, a process very similar to those that caused the seas of lava on our own moon. Other indications of the brutal forces of the meteoric impacts are the radial marks surrounding the craters. Here, more recent and therefore brighter meteoric rudiments are scattered around the point of impact. Larger craters are typically surrounded by ring-shaped walls, created through folding, another phenomenon reminding us of the makeup of our moon. Phenomena exclusive to Mercury are the so-called rupees, cliffs reaching more than a mile in height and stretching over 100 miles. The rupees cross right through a number of the meteoric craters, which makes scientific experts believe that these cliffs may have been caused by a shrinking of the planet. According to calculations, Mercury's overall diameter may have been more than 200,000 square miles bigger 4 billion years ago. Despite its similarities to our moon, Mercury isn't exactly a nice place to visit. That's because of its proximity to the Sun. The sun-facing half of Mercury is heated to extreme temperatures reaching up to 750 degrees Fahrenheit. On the night side, temperatures go as low as to minus 275 degrees. These conditions make Mercury the planet with the widest range of temperature spans. The day cycles are similarly extreme. A night on Mercury lasts pretty darn long. The sun only rises every 176 days due to Mercury's eccentric spin. And while you're waiting in the dark for the morning to come, Mercury does 2 rounds around the sun. At least it's safe to say, when the sun finally rises, it really shines hard. The distance between Mercury and the sun is only 30 million miles, just 1/3 of the distance between us and the sun. Standing on Mercury's surface, you would not only be exposed to massive heat, but also a lot of solar radiation, which is very hazardous to humans. Luckily, our nomads are not that susceptible. Still, I bet that little guy down there is getting pretty warm now.
Now, all of our comparisons about the moon and Mercury prompt a related question. What about Mercury's moon? Well, the answer is that just like Venus, Mercury doesn't have a moon. Now, this fact has led scientists to believe that perhaps Mercury once orbited Venus. Such a theory would explain why Mercury's orbital trajectory around the Sun is so irregular.
Geometrically speaking, Mercury's trajectory takes a gyrational form, as it was observed in the late 19th century. Astronomers at the time mistakenly interpreted it as proof of the existence of a previously unknown planet. In fact, they were so convinced by the evidence that they gave that phantom planet a name, Vulcan.
Now, while I still hope for the Vulcanians that they would live long and prosper, they would certainly have to do that someplace else.
Another very improbable location for their home would be the Helix Nebula in the sign of Aquarius. This celestial object was named Helix Nebula in the 18th century. Through early telescopes, the nebula looked similar to gas giants like Jupiter. More accurately, it's the remains of another supernova, an exploded sun. At the end of their life, stars blow their gaseous components far out into space. The remaining core, known as a white dwarf, keeps heating up these gas particles and thereby drives them farther and farther away. In the case of Helix Nebula, the result looks somewhat like a gigantic eye. This similarity becomes most obvious in infrared view mode, an eerie sight that is somehow fitting for the fatal events that took place in that extinct solar system. We can now see the white dwarf as a bright spot in the middle, while the most recently emitted gases are tinted in red. The blue-greenish elements are much cooler gas particles. When the explosion happened, all planets and moons of that nebular system were torn from their orbits and were either ripped to pieces by the gravitational forces or burnt down by the vastly expanding sun. At least some comets survived, and they continue to make their way through the galactic rubble.
And meanwhile, that huge eye of the Helix Nebula keeps staring into space. Maybe it's looking for that ring, you know? I mean, the rings of Saturn, of course.
Saturn is the sixth planet of our solar system. Located almost 1 billion miles away from Earth, it's incredible that it's visible to the plain human eye in our night sky. That goes to prove that Saturn is pretty big. To be exact, it has a diameter of about 75,000 miles, making it the second largest planet in our solar system. Looking through even the simplest of telescopes, the most striking feature of Saturn can be seen from Earth, Saturn's distinctive ring system. The stylized shape of Saturn with its rings has become a symbol for astronomy, spacefaring, and science fiction alike. Let's take a closer look at that disk that Saturn seems to be stuck in. Once we get closer, we can differentiate between a number of more or less sharply defined rings. There are over 100,000 separate rings around Saturn, each with different color tones mirroring their composition. The rings are visibly separated. You can easily sense the gaps between them. The material composition of the individual rings becomes pretty evident when we get up close. The rings are asteroid fields circling around the planet. In these rings, a diverse range of compounds of differing sizes whirl about, some as small as grains of sand. Some of the smaller moons of Saturn are plowing right through these rings. These moons are called shepherd moons because their orbits ensure that the rings are kept nicely in shape. Unfortunately, we cannot set foot on Saturn. Like all the gas giants, it doesn't have an actual physical surface. Its atmosphere consists mainly of hydrogen and helium. Towards the planet's core, the pressure rises to incredible magnitudes, prompting the gases to liquefy. What we can do is send our NOMAD into the outer atmosphere. Saturn has two distinctly separated cloud layers. From space, the lower layer isn't even visible because of the density of the outer layer. So the sight here is really rather rare. Now we're closing in on the whirlwind at the South Pole. This whirlwind is a hurricane with a fixed position and a diameter of 5,000 miles. The North Pole offers a similarly distinctive feature, a polar vortex in the shape of very tidy hexagons. This phenomenon stretches out over 15,000 miles and is several hundred miles deep. Since our NOMAD is already out here, it would be a wasted opportunity if we didn't embark on a touchdown somewhere. Fortunately, some of Saturn's 62 moons are really big fellows. 4 of them have diameters ranging from 500 to 1,000 miles. That's half the size of our own moon. And they also look pretty familiar. Firstly, there's Rhea. Exposed to temperatures of between -275 to -365 degrees Fahrenheit, its surface is made of water ice by 2/3. Thanks to gas emissions, Rhea has a very thin atmosphere made of oxygen and carbon dioxide. The surface is littered with craters, as on Earth's moon, but the craters appear visually softer. That's because Rhea's crust is more flexible than that of our own moon. Rhea's smaller sister, Dione, shares similar features. It's also mostly comprised of ice, but has more sharply drawn craters. Additionally, it has light stripes that are likely to have been caused by cold volcanism. Staying in the family analogy, Thetis could then again be the younger brother of Dione, as these two moons look almost identical. The most striking feature of Thetis is a giant impact crater named Odysseus. It covers close to 40% of Thetis' surface. Due to the orientation of that crater, Thetis may remind science fiction enthusiasts of a certain deadly battle station. This distinctly bicolored moon, Iapetus, on the other hand, reminds me more of the yin and yang symbol. A big part of its icy surface is tinted in a dark red. Scientists are still unsure of exactly how this pattern developed. Possibly different colored material may have emerged from within Iapetus through processes of volcanic activity or meteoric impact events. Another striking feature of Iapetus is a rift stretching over 800 miles. This formation is up to 8 miles high and somehow makes the moon look like a walnut when seen from a certain angle. Possible explanations for this anomaly include tectonic activities and crashed remains of an asteroid ring. The mini-moon Enceladus also has an interesting surface. It's very bright because it consists of almost flawless water ice, making it reflect 99% of all incoming sunlight. Enceladus is the most reflective astral body in our entire solar system. Another source of Enceladus's ever-fresh looks is its active cryovolcanism. Geysers keep renewing the surface by spitting out ice fountains of up to 300 miles in height. Analysis of the discharged material has shown a very high density of organic chemicals.
Such organic materials, in combination with water and moderate temperatures, form the basic components necessary for the creation of life. So it seems like the only thing preventing life on Enceladus is warmer temperatures. Now that's quite an exciting discovery, but one that will be topped by the last stop on our little tour of moons.
The biggest of Saturn's moons is a really big guy. In fact, it's even bigger than the planet Mercury and has therefore aptly been named Titan.
Titan holds a number of additional features, making it appear more like a full-grown planet in its own rights. And not just any full-grown planet. That is, Titan is even Earth-like. Yes, in fact, Titan is the astral body in our solar system that resembles Earth the most. But let's start at the beginning.
Titan has a diameter of 3,200 miles and is the only known moon to have a really dense atmosphere. This atmosphere is rich on clouds and consists mainly of nitrogen, although it carries traces of carbon hydride and other organic components too. The clouds are made up of methane, ethane, and other hydrocarbons. At Titan's surface, the average temperature is as low as minus 275 degrees Fahrenheit. Still, Titan has landscapes that look a lot like those on Earth. Along the equator, for example, lies a region called Xanadu, which is about the size of Australia. Here we find mountains of up to a mile in height. They were created by water ice that was washed down by methane rain, causing them to take their current shape. Due to the low temperatures, the ice is as hard as silicate rock. There is no water, of course. Instead, pools and even seas of methane define the landscape. Contrasting the methane seas are desert-like areas dominated by dunes. These landscapes have most likely been formed in a similar manner as dunes on Earth, by wind. Wind speeds as low as 2 miles per hour are enough to make these sandy particles shape into dunes. These dunes are several hundred miles long and up to 500 feet high and consist of sand particles that are about 1/10 of an inch small. These are made up of organic materials that dried after raining onto Titan's surface.
Now, with all these similarities to Earth, life is not out of the question. Because of the cold, it's impossible for water-based life forms to exist, but recent discoveries on Earth would suggest the possibility of life forms that are based on hydrogen. And Titan is practically teeming with hydrogen. So I'd say it's about time we send a couple of more rovers up there to look under every piece of icy rock. Maybe there are some microscopic aliens like bacteria and microbes up there on Titan. Maybe there once were in the past, or maybe they'll emerge in the future. We don't know. No one can say with certainty what sparks the ignition of life. One thing is sure, though. All life is part of an eternal cycle. This is true for suns as well. When one star explodes, a shockwave runs through space, carrying an incredible amount of energy. For example, in the case of the Crab Nebula, it was the equivalent of 100,000 suns. Now, this energy fuels the creation of new stars, and with them, new planets. We've seen what this process looks like. We saw the material shot out by dying suns form cosmic nebulas at first, only to later become part of new stars and planets. This is the cycle of cosmic creation. The byproduct is sights of incredible beauty. So why don't we let some of them unfold before us?
Here we have the American Nebula, for example, clearly named for its resemblance to the North American continent. This likeness is only noticeable in the visible light spectrum, though. In infrared view, the whole thing looks entirely different, but no less fascinating. A totally different visual experience is provided by the Rho-Oph Nebula. A mere 407 light-years away, it's the star factory closest to Earth. The 300 suns we find here have an average age of 300,000 years. That really makes them babies from a star's point of view. After all, the oldest discovered stars have been around for over 12 billion years. The Pleiades, also known as the Seven Sisters, are also readily visible from Earth. That makes them the subject of many old scriptures and legends. These suns were created when dinosaurs were still roaming the Earth about 100 million years ago. That makes the Pleiades quite a bit younger than our own sun, which has about 5 billion years on the meter. Some experts believe that our sun was born in a dense star-forming region like the Pleiades, and then later moved to its current position over the course of millions of years.
As you can see, there really is quite a lot going on out there in space, even if we haven't encountered any real aliens yet. But we still have 2 stops to make on our galactic tour de force. One of them is Jupiter, no less than the largest planet in our solar system. And we have over 80 moons to take a look at. Hey, welcome back to the International Space Station in the year 2057. We've been looking for alien life in our solar system and beyond. We've learned many interesting things about our neighboring planet so far, and also found some possible habitats for extraterrestrial beings, at least at the level of bacteria and microorganisms. Now today I have another surprising highlight, one that you possibly didn't even know existed, but more on that later on. We've learned about the creation of suns and their planets as well as their demise. Now, these are objects of incredible proportions, magnitude, and distances. Every huge object out there seems to have an even bigger sibling hidden somewhere. Today, let's begin by looking at our home world from really far away. By doing this, we can get a better feeling for the scale of our solar system and its context in the galaxy.
We are now looking at our own solar system with the Sun, the 8 planets and their moons, as well as some asteroids and the dwarf planet series. At the far reaches lie the Kuiper Belt, more dwarf planets, and many, many more asteroids. All of this covers an area of more than 4.7 billion miles in diameter. On one hand, this sounds incredibly large, but on the other, it's just a tiny fraction of the Milky Way. In our night sky, you can see parts of the Milky Way with your own eyes. It's visible in rural areas with little light pollution, looking like a brush of milky fog across the sky. What we actually see is the light of millions of faraway stars. They all belong to our galaxy, a word that has its origin in the Greek word for milk, gala. The ancient Greeks believed in a legend about the creation of the Milky Way. Supposedly, their chief god Zeus had tried to make his mortal bastard son Heracles breastfeed from his wife Hera. She pushed the infant away, causing some milk to be spilled across the skies. We see this scene here in an interpretation by the Italian painter Jacopo Tintoretto. The streak we can see in our night sky only represents a small fraction of the Milky Way. Since we reside inside it, it's not possible to get a real photograph of the entire Milky Way. Still, observations, calculations, and comparisons with other galaxies have given scientists a good representation of what our Milky Way looks like. Emerging from a central streak, two mighty spiral arms define its appearance. These arms are occupied by particularly bright stars. Our own solar system lies far out from the center of our galaxy. In this depiction, it can be found in the southeast. Altogether, our galaxy has a diameter of about 100,000 light-years. So if we traveled at light speed, around 671 million miles an hour, it would take 100,000 years to get from one end to the other.
This pretty much defies our imagination, so I'll scale it down to sizes that we can better grasp. Let's assume our galaxy was 10 miles square. In that case, our solar system would have the width of a single strand of hair. It would be just barely visible to the naked eye, and our Earth would be the size of a single atom. But before we get dizzy from imagining the proportions of how vast the Milky Way is, or how incredibly small we are, let's take a look closer to home. Even here, the scales are still hard to fully appreciate.
The planet Uranus is roughly 3 billion kilometers away. A supersonic jet would need at least 200 years to cover that distance. As we've already heard, Earth and Venus are considered to be sister planets because of their many similarities. Neptune even has a twin. It's been classed as Uranus. Like all twins, the two of them can be easily confused. Uranus is named after the god of the skies because compared to the deep blue shade of Neptune, it appears light blue with a touch of green. This is for the same reason as Neptune. The methane in the atmosphere is responsible for the color as it absorbs red light. Uranus and Neptune are richer with water, ammonium, and methane than the other two gas giants, Saturn and Jupiter. That is why they're in the subclass of the ice giants. And really, it's with good reason, as it's blistering cold on Uranus. For reasons still unknown, Uranus is the only planet that doesn't have an internal heat source of any kind. All of its energy comes from the sun, which is not much given it's 2 billion miles out. To be precise, Uranus receives only a 400th of the total energy reaching Earth. Due to the low amount of heat reaching the atmosphere of Uranus, it doesn't display as many weather effects as Neptune. There are the occasional cloud bands as large as 18,000 miles in length, but they dissolve pretty quickly. Possibly the inner cold of Uranus may have something to do with a horrendous meteor strike. This is a conclusion drawn from the fact that the axis of Uranus is severely tilted. Therefore, we mostly see Uranus top down when we look at it from Earth. In this perspective, the ring system makes it look a bit like an archery target, while the moons circle around their planet like hands on a clock. Having a ring system is common for gas giants, and again, Uranus's rings are similar to Neptune's. They're made up of very small, dark particles. The rings Mai and Ni are somewhat special because their composition makes them appear slightly red and blue, respectively. All the other rings are a dark gray. Again, we find some shepherd moons here that help keep the rings in shape by plowing through them. In total, Uranus has 27 moons, with diameters ranging from 6 to 1,000 miles. Their small sizes means that they're pretty lightweight. Together, they weigh less than Neptune's moon Triton alone. The 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon all look relatively similar, and visually they could be smaller versions of our own moon. To look at it, the most interesting is Miranda, because she has some very different surface structures, including heavy displacements, fragmentation patterns, and a labyrinth of canyons that runs up to 12 miles deep. This makes Miranda a unique astral body within our solar system. There are different theories about how these formations have been created. The most probable one suggests that Miranda once traveled into the gravitational reach of Umbriel and Ariel. These forces heated Miranda up, and because she's made of 80% water ice, this led to strong tectonic effects. After a while, Miranda broke free from those forces to assume her current orbit around Uranus.
Well, I don't know about you, but I feel slightly disappointed by Uranus. No actual surface to land on, no impressive weather effects, and the moons aren't too exciting either. If you've been to our Earth's moon, that is. So I think we deserve to treat ourselves now. And fortunately, space gives us plenty of opportunities for that. Since we've been looking at our Milky Way today, I'm going to additionally show you some of the most beautiful, distant galaxies out there.
Let's start with Messier 74. It's a classical spiral-shaped galaxy, not unlike our own. However, the arms of M74 are decorated with bright pink areas. Those are clouds of gases lit up by the light from young stars. These regions produce a large amount of ultraviolet light, hence the pink color. Much more asymmetrical is the appearance of Messier 66, the biggest galaxy of the Leo triplets. Its displaced looks are owed to the gravitational forces of its two siblings that are relatively close by, at least when speaking in galactic terms. Galaxies are drifting through space, which allows for occasional breathtaking compositions. For example, this pair of galaxies, known as ARP 273. Scientists assume that the smaller galaxy has fully passed through the bigger one, and as a result, created a form that reminds us of a rose. In a couple of billion years, our own galaxy may collide with our neighbor Andromeda. Something similar has happened with the antenna galaxies. These two galaxies merged when they crashed into one another, and the resulting forces have spawned billions of new suns, most of them in tightly packed groups called superstar clusters.
Those were some truly impressive images. It's a pity these galaxies are so far away. It keeps us from taking an even closer look at them. Nevertheless, we still do have one major planet left in our own Milky Way, and this one is almost a solar system in its own right. How is that possible? Let me show you.
We're now visiting the biggest planet of our system, Jupiter. It alone weighs more than all of our other planets added together. It is so huge that despite being 480 million miles from Earth, it's one of the brightest objects in our night sky. It was named after the Roman god Jupiter, a very long time before the invention of the telescope. The Babylonians called it the King's Star, and indeed, Jupiter reigns over its own little realm. With its 63 moons, some nearly planet-sized themselves, it can almost be described as a solar system of its own. Really, if Jupiter had only gained a little more mass, it probably would have ignited and become a sun itself. While that would have been spectacular, it obviously hasn't happened. But Jupiter does at least have a ring system. However, it's not too visually impressive. It's made of tiny particles almost comparable to cigarette smoke. These little grains are mostly black and therefore hard to see. Their origin is interesting, as they're made up of dust from the adjacent moons. Dust is produced from these moons when they're hit by meteors. Due to the low gravity of these moons, the debris is blown out into Jupiter's orbit, which has resulted in the main ring being mostly made up of dust from the moons of Andrastea and Metis. Another interesting fact is that the rings are moving closer to Jupiter on a spiral path. This happens because the strong magnetic field of the planet slows down the dust particles. In a far future, the rings will therefore be swallowed up by Jupiter. When we take a close look at the planet, the first thing we notice is the colorful atmosphere that looks somewhat like marbled rock. This hull of gas makes up almost the entire planet, because as with all gas giants, it becomes liquefied due to the rising pressure on the way down towards the planet's core. This core consists of a mixture of rock and ice, and is about 20 times heavier than our Earth. This means, once again, we have nowhere to land on Jupiter. So let's take an even closer look at the atmosphere instead. The most distinctive feature is the cloud bands that run in parallel to the equator. Then there's the big red spot, a gigantic whirlwind with a fixed position. Its diameter is 3 times that of Earth, and inside the wind speeds reach to 375 miles per hour. Its existence was already recorded in the year 1664. Sending our NOMAD through the outer atmosphere gives us a nice view, as Jupiter has 2 sharply separated cloud layers. The reason for this separation is differing temperatures. No less impressive is Jupiter's magnetic field. Like all things Jupiter, it is gigantic. It's 14 times stronger than Earth's magnetic fields, and its outer measurable limits almost reach out to Saturn. Of course, you cannot directly see a magnetic field, but interference with Jupiter's main moons causes gigantic auroras at the North Pole. These 4 moons orbit Jupiter fully enclosed by its magnetic field and are thereby shielded from solar radiation. Because of this, the moons seem particularly inviting. However, it took some real effort to make our NOMAD's electronics work in this environment. That dealt with, let's take the tour. At 1 million miles away from Jupiter, Callisto is its most distant moon. Actually, it looks pretty similar to our own moon, so I guess it's enough if we do a flyby. Closing in on Jupiter, we come across Ganymede next. At over 3,700 miles in diameter, this is the biggest moon of our solar system. It's even considerably larger than the planet Mercury. With its crater-littered surface and the very thin atmosphere, it also looks quite a bit like Mercury. Still, it is a bit more interesting as far as looks are concerned. Due to a mixture of different surface area types, it almost looks like it's been painted with a very wide brush. The next stop on our little tour is Io. It orbits Jupiter at a distance of 250,000 miles and needs 42 hours to complete one orbit. Even when looking from quite a distance, you might describe it as a hell of a moon. After all, the most distinctive structures on its surface are volcanoes and lava pools of gigantic dimensions. There are seas of liquefied sulfur, an element covering the entire planet in various aggregate states, from gaseous to liquid to solid. This gives Io a pretty colorful appearance, with yellow being the predominant hue. Surface photographs of Io, separated by only 20 years, show vastly different features. On taking a closer look, it becomes clear why its surface is subject to constant change. Of all bodies in our solar system, Io has the most active volcanism. The constant eruptions hurl lava that is 2,000 degrees Fahrenheit up to 180 miles into the air. Aside from the lava pools that are up to 250 miles wide, there are also rivers of lava with temperatures of up to 3,500 degrees Fahrenheit that flow hundreds of miles. Despite the heat generated by the volcanoes, the average surface temperature of Io is a low minus 236 degrees Fahrenheit. I guess you could really call this a harsh environment. So if there should be any life on Io, it's definitely got to be tough as nails. Still, it's getting even more exciting. We're closing in on Europa. This moon lies 370,000 miles away from Jupiter and is covered with an ice crust 6 miles deep. This makes Europa look a lot like Neptune's moon Triton. Europa has a very thin atmosphere, mostly made up of oxygen. The red coloring is caused by accumulation of minerals. Europa's surface is among the smoothest and youngest. There are hardly any structures that rise more than 300 feet above the surrounding grounds. Still, the network of chaotic ridges and trenches is visually striking. These so-called linea are up to 12 miles wide and are strongly reminiscent of ice fields on Earth. Since the positions and alignments of the linea cannot be explained by geological processes, they are a clue to one of the biggest secrets of our solar system. Under Europa's icy crust lies a vast ocean of liquid water. This water interacts with the surface, and the linea are created. Due to the irregular orbit of Europa, strong tidal forces affect the ice and heat up the inside. So it's time to do a couple of miles of drilling and to activate NOMAD's submarine mode. As I said, the prerequisites for the creation of life are organic chemicals, water, and warmth. And all of this is theoretically available in Europa's ocean. On Earth, there are examples of organisms that are totally independent of sunlight. Such life forms are only very primitives of nature, like microbes or endoliths. Yet there are theories that suggest that cosmic radiation may cause release of oxygen in Europa's water. The waters here could already be more oxygen-rich than our earthly oceans, which would mean... What the? Did you see that? What in...
I'm sorry about that, but I'm afraid I just couldn't resist a little joke. Of course, this was only fiction, but maybe after all, not that far from reality. Speaking for myself, I'm absolutely sure that somewhere out there is life, maybe even intelligent life. And having heard about distant galaxies today, you may be intrigued about the possibility of life elsewhere yourself. So I'll just let more images argue my case.
Look at this image. At first glance, you might think it's a typical snapshot of our night sky with a lot of stars. Actually, this isn't too far off. The surprise lies in the fact that it represents only an incredibly small fraction of what is actually floating around in our night sky. To be precise, it's only a tenth of the space the moon takes up in our field of view. And what we see shining there aren't just stars. Most stars would be much too small and dim to be seen here. No, all these little lights are full-blown galaxies. Just imagine this. Behind a piece of our sky about the size of a fingernail, there are more than 10,000 galaxies. And I'm talking galaxies, not solar systems. Each of these contains up to 100 million solar systems, just like our Milky Way. So even if skeptics are right in their assumption that there is no other case of intelligent life forms in our entire galaxy, what about the probability when we multiply these chances by 1 trillion? These odds are why no one can rip me from my belief.
So you've probably noticed that I'm a big fan of our planets, moons, and the secrets waiting to be discovered in space. I hope that I've been able to pass on some of my enthusiasm. Yet it saddens me a bit to see that the golden days of spacefaring seem to be over. I hope that you'll reflect on what you've learned, maybe even ponder a bit on the idea of possible aliens, or just acknowledge the place of our little Earth in this gigantic cosmos. On that note, I'm sorry to say it is time to leave. It's been a pleasure being your guide around the cosmos, and I hope you've learned a great deal. So for now, I'll be saying goodbye. Oh, sure. Nomad asked me to tell you goodbye too. So, take care from me, Matt Sabernack, and Nomad. See you again. Bye-bye.